Namaste children. So we are discussing the first chapter, number systems. In the last class we discussed about the representation of real numbers on the number line, that is by using the successive magnification method. And now today we are going to discuss about operations on real numbers. Operations in the sense arithmetic operations, that is addition, multiplication, subtraction and division. So real numbers again they includes rational numbers and it is irrational numbers. So we have studied the operations on rational numbers in the previous sections here of different properties. That is rational numbers satisfies commutative property, associative property, distributive property under multiplication and addition and multiplication. So here also this irrational numbers also satisfies commutative property, associative property and distributive property under addition and multiplication. And also we have studied about the rational numbers are closed under multiplication, addition, subtraction and even for division except for 0. Thus the closure property is satisfied by rational numbers under for closure property. That property is satisfied. Now we are going to discuss that closure property, that is sum of two irrational numbers, difference of two irrational numbers, multiplication of two irrational numbers and the division of two irrational numbers, or one rational and one irrational number will what is the nature of that kind of that numbers, whether they are rational or irrational, we are going to discuss in this chapter, that is operations on real numbers. Especially we will concentrate on irrational numbers because we have already covered rational numbers. What it is, operations are rational numbers. Yes, the first, that is operation, we take it as addition. So under addition what happens it is, so sum of two rational numbers is also a rational number. We have studied. Take any two rational numbers, 1 by 3 plus what is 2 by 3, that is equals to 3 by 3, which is equals to 1. It is a rational number. Q stands for rational number. Or you take any other numbers, 4 by 7 minus 1 by 7, that is 3 by 7. We get 3 by 7 is also a rational number. That is sum of any two rational numbers is always a rational number. Sum of any two rational numbers is always a rational number. Now what about the two irrational numbers? Yes, root 2 plus root 3. Root 2 plus root 3 we get root 2 plus root 3 only, that is also that is an irrational number. So in this case sum of two irrational numbers is an irrational number. The addition of two irrational numbers is an irrational number. Now what about this? Root 3 plus minus root 3. Here we are adding two irrational numbers. Root 3 is 1 and minus root 3 is 1. Two irrational numbers we are adding. So how much we get root 3 plus minus root 3 is 0. 0 is a rational number. 0 is a rational number. Here the sum of two irrational numbers is a rational number. So what we can conclude? Yes, the sum of two irrational numbers need not be a rational number. It may be rational or it may be irrational. Sometimes it is rational and sometimes it is irrational. So what about one rational and one irrational? One rational and one irrational, like this. 2 plus root 2. 2 plus root 2 when we add irrational. Root 2 to 2 or 3 plus root 7. So their sums will get an irrational numbers. Why they are irrational numbers? Because root 2 it is a non-terminating, non-recurring decimal. Non-terminating, non-recurring decimal. Root 7 also non-terminating, non-recurring decimal. To any non-terminating, non-recurring decimal, if you add what it is a rational number, we will get always again it is a non-terminating, non-recurring decimal, which means the sum is a irrational number. That is sum of one rational and one irrational is always sum of one rational and one irrational is always an irrational number. Sum of two rational numbers is always a rational number. Sum of two irrational numbers is maybe irrational, maybe rational. There is two possibilities are there. It may be a rational or it may be a irrational number. Now the second arithmetic operation is subtraction. So under subtraction, so the difference of any two rational numbers, 4 minus 2 is equals to 1. It is a rational number. 1 is a rational number. So I'm sorry. Here we are taking the addition. 4 by 7 minus 1 by 7. Please take this as the addition. We are under addition. 4 by 7 plus 1 by 7 is equals to what it is? 5 by 7. 5 by 7 we get. So it's a small correction. 5 by 7 is also a rational number addition. Under addition. Now subtraction. The difference of two rational numbers, 4 minus 2 is equals to 1. 1 is a rational number. Now 4 by 7 minus 1 by 7 is equals to 3 by 7. It is also a rational number. So the difference of any two rational numbers is always rational number. What about irrational numbers? Yes. Root 3 minus root 2. It is an irrational number. Root 3 minus root 2. It is an irrational number. Because both are non-terminating, non-recurring decimals. Their subtraction also will get a non-terminating, non-recurring decimal, which is an irrational number. Now, root 3 minus root 3. Root 3 minus root 3 is equal to, it is 0. When you subtract a number from same number, you get 0. So 0 is a rational number. So again, what we can conclude from here it is the difference of two irrational numbers is a rational number. The difference of two irrational numbers is an irrational number. So it is not necessary always that the difference of two irrational numbers is an irrational number. Now you take for this one rational and one irrational. 2 minus root 2 or 3 minus root 7, both are what the irrational numbers. It means the difference of a rational and an irrational is always an irrational number. The difference of a rational and an irrational is always an irrational number. Because root 2 and root 7 both are non-terminating, non-recurring decimals. If they are subtracted from a rational number, we also get again non-terminating, non-recurring decimals only. Right now, so under multiplication, the next operation is multiplication. So under multiplication, what it is? Multiplication, yes. 3 into 4 is equals to 12. It is a rational number. 1 by 4 into 3 by 7, that is equals to 1 into 3. 3 by 4 into 7, 28. It is also a rational number. 3 by 28 is also a rational number. That is, product of two rational numbers is always a rational number. Now, what about two irrational numbers? Root 3 into root 3 is equals to root 9. That is, root 9 is 3. It is a rational number. Product of two rational numbers is a rational number we got. Now, root 2 into root 3 is equals to root 6, which is an irrational number. That is an irrational number. So it means the product of any two irrational numbers is need not an irrational number. It means it may be a rational or it may be an irrational number. What about the rational number and an irrational number? Yes. 2 into root 2 is equals to 2 root 2. It is a rational number. 3 into root 7 is equals to 3 root 7. It is also an irrational number. That is, the product of one rational and one irrational is always an irrational number. The product of one rational and one irrational is always an irrational number. Now what about under division? The last concept it is a division. So what happens to this division? So division. So the division of two rational numbers. Division. Yes. 1 divided by 4 is equals to 1 by 4. Then 3 divided by 7 is equals to 3 by 7. So they are rational numbers. They are rational. That is the division of two rational numbers. The quotient of two irrational numbers when we divide is always a rational number, but except for 0. If you divide 1 with 0, 1 by 0, it is not defined. Not defined means except for 0. Except for 0, the division of any two rational numbers is always a rational number. except for 0. The division of any two rational numbers is always a rational number. What about the two irrational numbers, their division? Yes, root 3 divided by root 3 is equals to 1. 1 is a rational number. 1 is a rational number. Next, we take one more example. Root 2 divided by root 3. It is an irrational number. This is an irrational number. It means that the division of two irrational numbers need not be an irrational. It means it may be a rational or it may be an irrational. Now, what about one rational and one irrational division? Yes, it is 2 divided by root 3. 2 divided by root 3 is an irrational. 4 divided by root 5. Root 5. Both are not that irrational. The irrational. So, what we can conclude from this, that is the division of one rational and one irrational is always an irrational number. So this is related to the closure property. That is, closure property is satisfied by rational numbers under all arithmetic operations except for 0. It is division is not satisfied. What about irrational numbers? It is not satisfied because the addition, subtraction, multiplication, division of two irrational numbers is not always an irrational. It is not always an irrational. Similarly, that is the addition or subtraction or multiplication or division of one rational and one irrational is always an irrational number. So using this property, we can identify which of the following are irrational or which of the following are rational. Is it clear, children? These operations are real numbers. Now, with this knowledge, what we study, we will solve some of the questions. Example 13. Add 2 root 2 plus 5 root 3. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. We have to add these two. So, yes, 2 root 2 plus 5 root 3 is added to root 2 minus 3 root 3. Now, write these irrational numbers with the same, what I will say, radicand. Root 2, 2 root 2 and root 2 both are similar terms. Write similar terms together, 2 root 2 and root 2 plus 5 root 3 minus 3 root 3. So 5 root 3 minus 2 root 3. Again we are applying here algebraic expressions concept. 2 root 2 plus 5 root 2. Here 2 is the coefficient of root 2. And for root 2 here the coefficient, there is no number, means it is 1. So add the coefficients and take the common term. So 2 plus 1, it is 3. 3 root 2 plus 5 root 3 minus 3 root 3. So 5 is the coefficient for root 3 and here it is minus 3. Subtract these two numbers. 5 minus 3 is 2. 2 root 3. Or you can write the coefficients at 2 plus 1, that is root 2, plus subtract the coefficient 5 minus 3, that is root 2. So how do we add irrational numbers if they have the same common coefficients, that is root term is the same? Add the coefficients or subtract the coefficients for subtraction. Now 2 plus 4 it is 3, 3 root 2 plus 5 minus 3 it is 2, 2 root 2. So this is, 5 minus 3 is 3, root 3. Therefore it will be 2 root 3. 3 root 2 plus 2 root 3 we get by adding these two terms. Next, under multiplication. Multiply 6 root 5 by 2 root 5 means 6 root 5 into 2 root 5. Yes, how do we multiply? First multiply the arithmetic signs, plus into plus. When multiply the coefficients, here 6 and 2 are coefficients. Multiply the coefficients. 6 into 2, 6 2s are 12 into root 5 into root 5. Root 5 into root 5 it is root 5 whole square, or root 5 into root 5 it is root 25. Root 25. That is, here we have the identities. Root a into root b is equals to root a into b. That is 5 into 5 is 25. 12 into root 25 it is 5. So 12 into 5, it is 12 5s are 60. So when we multiply 6 root 5 to 2 root 5, we get 60. Root 25 is 5, and also we have minus 5 also is there, but we will consider only the positive square roots. Now division. Under division, divide 8 root 15 by 2 root 3. So 8 root 15 is divided by 2 root 3. Yes, they are divided by 2 root 3. Now you see, identify the common factors. Here both coefficients are divisible by 2. 2 is the common factor. 2 1s are 2 4s are 8. Now what it is? 4. Root 15 can be written as root 3 into root 5. Root 3 into root 5, because in the denominator we have root 3 is there. If we find any common terms, you can split them and write in the form of factors. That is prime factorization. 3 into 5, 5 root 3. Now it is 4 into root 3 into root 5 by root 3. So root a into b, root a into b is equals to root a into root b. Root ab is equals to what? Root a into root b. This form we are using. Now here root 3 and root 3 are cancelled. Then what is left? It is 4 root 5 is left. 4 root 5 is the answer there. Here what identity we used? Here it is root a into root b is equals to square root of a into b, that is ab. So this identities also we use to simplify this. So here we have divided two irrational numbers. We got a rational number. So multiplied two irrational numbers. We got a rational number. And here we have divided two irrational numbers. We got one irrational number, and here we have added the rational numbers and we got irrational numbers. It means that the multiplication or the addition or the subtraction or the division of irrational numbers need not be an irrational number. We can conclude from these examples. Is it clear, children? Yes. Now we will discuss representing some more real numbers on the number line, which are under square root, decimals under square root, like root 3.5 on the number line. So here we are using again the concept of Pythagoras theorem, what we have discussed for the irrational numbers. How do we represent the root 3.5 on the number line? Here we have few steps are there. Those steps we need to follow to represent square root of 3.5. First step is draw a line segment AB is equals to 3.5 centimeters or 3.5 units. Draw AB is equals to 3.5 centimeters or units, you can write 3.5 units. AB is 3.5 units. First step, what is that? Draw a line segment. Draw AB is equals to given number, that is 3.5 units. 3.5 units. Then from point B, extend AB to C. Extend AB to C such that BC is equals to 1 unit. Such that BC is equals to 1 unit. So second step, what it is? Extend the AB. Extend AB to C such that what? AC is equals to 1 unit. Now how much is AC? Such that BC is equals to 1 unit. BC is equals to 1 unit. Now AC is equal to how much? Yes. Here AB is equals to 3.5 units. BC is equals to 1 unit. Then AC is equals to AB plus BC. AB plus BC, that is 3.5 plus 1 is equals to 4.5 units. AC is equal to how much it is? 4.5 units. So that extension is over. Then what? Locate this center, midpoint of AC. Locate midpoint of AC and take that as O. So third point, locate midpoint of AC as O on AB. So locate the midpoint of AC. Locate midpoint of AC on O as O on AC. On AC, the midpoint is O. How do you locate it? Yes, by using the concept of perpendicular bisector you use and you locate it. Just for example, this is the midpoint. I have taken this as point O. This is point O, point B, point C. How do you locate? Yes, by taking half of the length of AC as the radius. Draw two arcs from point A, one above and one below, and from point C, one above and one below. You can draw and where they intersect. You join them, you will get a perpendicular bisector that passes through the midpoint. Or you can use ruler to locate the what it is the midpoint of that line AC. Let this is point O is the midpoint. Now OA is equals to OC, that is midpoint. How much it is? Half of AC. Half of AC, that is AC by 2, which is 4.5 by 2. OA is equals to OC, that is equal to how much? 4.52 units. Now OB is equals to how much? OB, this length we have to find. OB is equals to AB minus OA. This total length AB minus OA. OB is equals to AB minus OA. That is equals to AB is equals to 3.5 units minus OA is equals to 4.5 by 2. Simplify this. 2 is the LCM. 7.0 minus 4.5 we get. That is equals to 2.5 by 2. So OB is equals to how much it is? 2.5 by 2. So how we got 7.0 it is 3.5 is this 3.5 by 1. So when we divide 2 with 1 we get 2. 2 into 3.5 is 7.50. Now we got it. Yes. Now after locating the midpoint, taking OA as the center or OC as the taking OA or OC as the radius and O as the center, draw a semicircle. Yes, you draw a semicircle taking O as the center, OA or OC as the radius, draw a semicircle. So what is the fourth step? Taking O as the center, taking O as the center, taking O as the center and OC as the radius, draw a semicircle. Yes, like this we will draw the semicircle. Next, what to do? Yes, at point B, draw a perpendicular to AB. Draw a perpendicular to AC at point B here. Draw a perpendicular. Yes, this is the perpendicular. So use protractor and draw, or use compass. Draw a protractor. Draw a perpendicular from point B to AC, which intersects the semicircle at point D. So this point is D. So next fifth step is what? At point B, draw a perpendicular to AC, which intersects the semicircle, at point D. Yes, at point D. Now, the length of BD will give you root 3.5. The length of BD will give you root 3.5. How it is root 3.5? I will explain. So, length of BD will give you what? Square root of 3.5. Square root of 3.5. Next, what to do? Sixth step. So consider AC is the number line and you extend it. Consider AC is the number line and you extend it to some point X. And consider B as 0 on the number line. Consider point B as 0 on the number line and C is 1 unit. Then you take one more digit, that will be the 2 units, then 3 units, 4 units, 5 units, like this we get. After that, taking B as the center and BD as the radius, draw an arc. Draw an arc which intersects the number line at a point. Consider this point is E. Point E represents square root of 3.5 on the number line. So what is sixth step? Taking B as the 0 on the number line. Consider AC is the number line and B is 0. Now draw an arc from point B, taking BD as the radius which intersects the number line at point E. Point E will represent root 3.5 on the number line. Where that arc intersects, that point will represent root 3.5. So sixth point what? Consider AC is the number line. AC is the number line and B as 0, C as 1, C as 1. Draw an arc from point B, taking BD as the radius, which intersects the number line, at point E, 7th step. Now point E represents square root of 3.5 on the number line. Yes. So point E represents square root of 3.5 on the number. Like this we can represent any number which is there under square root, any real number under square root. First step, draw a line segment AB which is equals to 3.5 units. Second step, from point B, extend AB to C such that BC is 1 unit. Then locate the center of the midpoint of AC. Let that point as O. Then taking O as the center, OC or OA as the radius, draw a semicircle. Then at point B, draw a perpendicular to AC which intersects the semicircle at point D. Now the length of OD will give you, the length of BD will give you what? Square root of 3.5. Square root of 3.5. That we can prove by using the Pythagoras theorem. Then consider AC is the number line and B represents 0, C represents 1 and next points represents the other values like number line. Then consider point B as the center and BD is the radius. Draw an arc which intersects the number line. That intersection point will represent square root of 3.5 on the number line. Is it clear, children, how to represent root 3.5 on the number line? Yes. Now we will discuss how can you say that this BD is root 3.5. Yes. Yes, I said BD is root 3.5. How do we prove? Join OD. Now it is a right angle triangle. It is a right angle triangle. Which one it is? In triangle OBD angle B is equals to 90 degrees. Apply Pythagoras theorem. Therefore, what we get? OD square, hypotenuse OD square is equal to sum of the squares of other two sides, that is OB and BD. OD square is equals to OB square plus BD square. Now OD is equal to how much? What is OD here? OD is the radius of the semicircle. That is OD is equals to OA is equals to OC. All are equal the radii of the semicircle. We know OA is equals to 4.5 centimeters, 4.5 by 2 units. Therefore, OD is also equals to 4.5 by 2 whole square. That is equals to OB square. OB we got how much? 2.5 by 2 whole square plus BD square. Now transpose 2.5 by 2 whole square to other side so that we can find the BD square. Now what we get? 4.5 by 2 whole square minus 2.5 by 2 whole square, that is equals to BD square. That is equals to BD square. Now it is in the form of A square minus B square form. That is A plus B into A minus B, which is 4.5 by 2 plus 2.5 by 2 A plus B into A minus B is 4.5 by 2 minus 2.5 by 2, that is equals to BD square. That is equals to BD square. Now 4 denominators are same, then add the numerators. 4.5 plus 2.5 is 7.0, or it is 7.0 is multiplied with 4.5 minus 2.5 is 2 by 2, that is equals to 1, which is equals to BD square. Now 7.0 means 7 by 2 is multiplied by 1. So what we get? 7 by 2 is multiplied by 1. We get 7 by 2, that is equals to BD square. Now transpose square to LHS, it will become square root. It will become square root. That is square root of 7 by 2 is equals to BD. That is square root of 7 by 2 is equals to what? 3.5, which is equals to BD. When we divide 7 with 2, what we get? 3.5. Therefore, BD is equals to how much? Square root of 3.5. Like this we can prove, as I said, the length of BD will give you the required line, required number. The length of BD will give you a required number, that is root 3.5. That line segment will give you the length of what it is, root 3.5. Here in this question. Like this you can represent the numbers which are there under square root on the number line. I hope you understand this. Thank you very much.